Howdy! In this mini lecture we will discuss the science behind global climate change and current and future impact of climate change. The student learning objectives of this mini lecture are: distinguish between global change, global climate change, and global warming, thoroughly explain the greenhouse effect, distinguish between solar and infrared radiation, identify the greenhouse gases and their sources. People often confuse and misuse the terms global change, global climate change, and global warming. You should understand the subtle but important differences between these terms. To begin, global change is the change in the chemical, biological, and physical properties of Earth. Examples of global change include rising sea levels, decreased biodiversity, overharvesting or exploitation of plants and animals, and global climate change. Notice that global climate change is just one type of global change. Global climate change is quite simply changes in Earth's climate. These changes include stronger storms, altered patterns of precipitation and temperature, changes in patterns of ocean circulation, and global warming. Again, notice that global warming is just one of the many types of global climate change. Global warming is the increase of the Earth's average temperature. Examples of global warming include warming of the Earth's land, air, and water, increases in occurrences of heat waves, and decreases in occurrences and duration of cold spells. The take-home point from all of this is that global warming and climate change are not synonymous. Understanding climate change requires understanding how our planet's climate works. For this reason, it is important that you understand the differences between these concepts. In addition to understanding how Earth's climate works, you also need a complete understanding of the greenhouse effect. This image illustrates this concept well. The sun emits solar radiation, which travels through space to reach our planet. The Earth absorbs about 70% of the solar radiation it receives. The radiation that is not absorbed may be absorbed by the atmosphere, reflected by the clouds or aerosols in the atmosphere, or is reflected by the Earth's surface. Yellow arrows in this figure represent the energy from the sun. The radiation absorbed by the surface of the Earth is re-emitted. It is very important to note that incoming solar radiation is energy with a shorter wavelength compared to the infrared radiation that is re-emitted by the Earth. This is why the solar radiation is referred to as a shorter wavelength radiation, and the infrared radiation re-emitted by the Earth after absorbing the solar radiation is referred to as a longer wavelength radiation. After the longer wavelength infrared radiation is re-emitted by the Earth, gases in the atmosphere absorb some of this radiation and re-emit it. This causes some of the infrared radiation to warm the lower atmosphere, for example the troposphere, and some to warm the surface of the Earth. That radiation is then sent back to Earth. This is the greenhouse effect. The greenhouse effect is natural. Without it, our planet would be much colder and possibly uninhabitable. However, we have exacerbated the greenhouse effect by adding large quantities of infrared trapping gases to the atmosphere. These gases are called greenhouse gases and include water vapor, H2O, tropospheric ozone, O3, carbon dioxide, CO2, methane, C4, nitrous oxide, N2O, and halocarbons, such as CFCs. Not all of the previously mentioned greenhouse gases contribute equally towards the greenhouse effect. This is a table that illustrates the global warming potential of 4 of the greenhouse gases. Global warming potential is essentially the relative heat-trapping capacity of a particular greenhouse gas. The values shown on the right of the table are expressed in relation to carbon dioxide, or in other words, how many carbon dioxide molecules would it take to equal the heat-trapping capacity of various greenhouse gases. As you can see, nitrous oxide is 298 times more potent than carbon dioxide. This table might be confusing because most people associate carbon dioxide as the main culprit of the greenhouse effect, but this table suggests that carbon dioxide isn't as potent in terms of trapping heat as methane, nitrous oxide, or hydrocarbons are. While this is true about the potency of carbon dioxide, what is also true is that carbon dioxide is far more abundant than any of the other gases listed here. Carbon dioxide also has a longer residency time than methane. For this reason, carbon dioxide contributes more to the greenhouse effect than the other, more potent gases. Specifically, CO2 is causing 6 times more warming than methane, nitrous oxide, and halocarbons combined. You're probably aware that many of the greenhouse gases are added to the atmosphere by the burning of fossil fuels. Since the start of the Industrial Revolution, which spanned from approximately 1760 to 1840, the global concentration of CO2, methane, and nitrous oxide has increased at an exponential rate. While it is true most greenhouse gases have been in our atmosphere for all of Earth's history, we have intensified the greenhouse effect by increasing the concentrations of several natural gases over the last 250 years. Halocarbons are entirely synthetic and are only in the atmosphere because of our actions. The main cause of an increase in the amount of carbon dioxide in the atmosphere is because we are burning fossil fuels, which releases carbon stored in the lithosphere and emits it into the atmosphere. The secondary cause is deforestation, which removes the forest as a reservoir for storing carbon and eliminates the organisms that are able to absorb, store, and use carbon dioxide. Methane concentrations have risen because of fossil fuel combustion and large-scale livestock production. Nitrous oxide is released as a byproduct of feedlots, chemical manufacturing plants, vehicle emissions, and synthetic fertilizers. Ozone concentrations in the troposphere have risen because of the photochemical smog. Halocarbons also contribute to global climate change. However, their contribution has lessened due to the Montreal Protocol and the subsequent international agreement to control the production and use of these gases. Water vapor is a naturally occurring gas and contributes to the naturally occurring greenhouse effect. However, because its concentration hasn't changed, it is not associated with driving climate change. That concludes this mini lecture on global climate change. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!